All right, so your remainder theorem is what we've been talking about. When you take a function and divide it by a factor, the remainder should be the same as whatever f of that root would have been. So in this case, x minus 3, if I want to find what the remainder is supposed to be, I plug in a 3. So that's all what you guys know from before that is 3 negative 14 then is a point on the graph. But the remainder is negative 14. So for B, we just do f of negative 2. We get negative 8 minus 16 minus 5, negative 29. What's that? If you're dividing by x plus 1, you plug in negative 1. What is negative 1 to the 19th power? That's a great question, Mrs. Rahel. Good. And so then this is where it also comes into play that if you do get a remainder of 0, going back to the point I made up here, we plugged in 3, we got a remainder of negative 14. That's the point 3 negative 14. If you plug in 3 and you get a remainder of 0, then the point would have been 3, 0, and 3, 0 would therefore be a root. Anything with a y coordinate of 0 is a root. So therefore anything with a remainder of 0 is a root. So that's all that's saying it in both ways. If f of c is 0, then x minus c is a factor, and vice versa. If you know it's a factor, then you know it's a root. So use the factor theorem to determine whether the function has the factor. Why does it want us to use synthetic division? Why can't we just plug in 1? I would just plug in 1. And I get 4 minus 4 is 0. So, yes. And then, Brock, what am I plugging in here? And that would be a big no. Are we good? Okay. I'm going to give you your homework. You're going to do your homework. If anyone sleeps or if anyone brings the volume level above what I'm comfortable with, we're going to move on to tomorrow. So just keep it peaceful. Do your work. Tomorrow's notes.